Okay, so here's a video that I hope will help with the current homework. And the first video I want to make is a very short one here that gives you an update on, or just a reminder on decibel units. Okay, so as of this point in the semester, there are three things that we use decibel units for. The first is for loss. Okay, and anytime you have a number, you can convert that number into decibel units. So let's start with a number. We can convert a number n into decibel units, any number n into dB, by taking 10 log base 10 of that number. Okay, that works for any number. We can put it into decibel units. Okay. The numbers we're interested in converting into decibel units for the case of loss is the loss ratio, which is P out over P in. Okay, and this gives the fraction of power lost as we go through a medium. So I'll draw the medium as a little pipe here and put P in and get P out. Okay, and so with a loss ratio, what we do is we say that the loss in dB is 10 log 10 of P out over P in. Because P out is less than P in when we have actual loss, taking the log of a negative number yields a negative number, and we want our loss to be a positive value, so we put a minus sign here. Okay, so this gives us, for example, a loss of 20 dB when P out is equal to 0.01, that is 1% of P in. Okay, so there's a quick example. So that's the first case in which we're using decibel units in the loss. Okay, and it has this minus sign here because we want losses to be positive values when the output signal is less than the input signal. The second case is power. And in this case, the number that we're converting into decibel units is equal to the power as a fraction of 1 milliwatt. And so what we do is we say that the power in dBm is 10 log 10 of the power in milliwatts divided by 1 milliwatt. So if you have your power in milliwatts, all you have to do is take log 10 of it and multiply by 10, because dividing by 1 doesn't really do anything. But make sure your power is in milliwatts before you do this. Okay, and so for example, P in dBm is equal to 0 dBm when the power is equal to 1 milliwatt. Okay, so there's a quick example of that one. Try to keep everybody in their place here as far as this piece of paper. And finally, the third one is in signals to noise ratio. This is the most recent addition to our list, in which case the number that we are converting into decibel units is the ratio of two powers. S and R is equal to the signal divided by the noise. Signal power divided by noise power. Both of them have to be in the same units of milliwatts or watts. Let me just call it milliwatts for convenience sake, but they could be watts. But remember, you do not divide signal and noise powers when they're in dBm. Okay, when they're in dBm, it becomes simpler, and so the the signal to noise ratio in dBm, can you see it? Yeah, is equal to 10 log 10 of the signal divided by the noise, where inside here these are in milliwatts. Okay, but by the laws of exponents, this is 10 log 10 of the signal power minus 10 log 10 of the noise power, which is really just the signal in dBm minus the noise in dBm. Okay, and so because the log of a ratio is the difference of the logs, what happens is the signal and noise ratio in dBm just becomes the difference of the two values in dBm. And this is why we can make a sort of a number line, I usually draw vertically, of signal power and noise power, and it's just the difference of the two that becomes the signal to noise ratio in dB. Okay, and this is fundamental to the way we work with power and loss in our problems where we're doing loss budgeting. Okay, hope that helps. Just remember that all the loss budgeting problems are very easy. It's just up and down on a number line. Once we get units into dB and dBm units, once everything's converted into decibel units, loss budgeting problems are quite easy. Thanks.